All right. Good afternoon. Nice to have you here on late afternoon. Do you enjoy SUSECON so far?
Yep.
Wonderful. Yeah, my name is Martin Weiss. I'm working for SUSE Consulting in EMEA. With me, I have Mark Connolly, also working for SUSE EMEA, SUSE Consulting EMEA. Basically, we have written some sort of title here, but I don't know if that's the right one. Just call us consultants, and we do whatever we can help with. Basically, what we are going to talk about is a bit of experience that we had in the past, where we went through deploying SUSE Enterprise Storage in different environments. So basically, I want to give some sort of a guideline, what helped us in the past, which steps we should go through to be successful with deploying SUSE Enterprise Storage based on Ceph. First of all, a quick survey. Anybody here already using Ceph? Oh, so you already have done that. Why are you here? So, yep. Yeah, you want to say a few words about you? No.
As Martin said, my name is Mark Connolly. I'm a consultant working in Europe on typically anything that has the word cluster in it. This is one of those things. So,
all right. So basically, this is not a deep technical thing we're going through. So basically, we will talk a bit about what is SUSE Enterprise Storage. Who is already on SUSE Enterprise Storage 5 or 5.5? So most of the people might already know that. So this is just a recap, quickly to tell you what we're talking about for the ones that don't have these experiences. Then we will talk about what are the basic requirements you should have a look at before deploying SUSE Enterprise Storage or Ceph in general. We will talk a bit about the planning and sizing topic. What are the steps you should go through? Then what are the deployment best practices so far? And a bit about the topic testing. Yeah, and that's it. So, and hopefully we do it within an hour. We'll see. So first of all, what's SUSE Enterprise Storage 5.5? Basically, it's just a software-defined storage based on open source software. Basically, you can take any piece of server, install the software, and consume the storage behind it. That's the idea. With SUSE Enterprise Storage 5 and 5.5, this is based on Ceph Luminous. And one of the most important things there is that we got BlueStore. That's the way how we store the data on the disk. And with that technology, we also got the functionality that erasure coding can be used natively for CephFS and Rados block devices, which is a big advantage since we have that version. So maybe also another question here, who is using BlueStore already? Somebody on FileStore still? Oh, wonderful. Replication, erasure coding, not too many in erasure coding now. So one of the reasons historically why not too many people are using erasure coding was exactly this missing feature, where we didn't have the chance to use erasure coding when using Rados block devices or CephFS. So this feature is now there, so now we can really use it.
can I say something there about that, Martin? Historically, as Martin said, you needed, if you wanted to do erasure coding for RBD, you needed this cache tier. And some customers historically have got themselves in trouble with this, because the problem with doing cache tiers is that all your active data kind of has to fit in the cache tier. Otherwise, the cache misses become painfully obvious. And we have a customer who has, over the years, thrown more and more hardware at the cache tier because the misses, to the extent that their cache tier is now 60% of the capacity of the backend store. And it's full.
And the setup is not very trivial. It's complex to set it up properly to work for your workload. Yeah. So basically we don't have to have the cache tier now anymore, and that's a big value. The whole system supports or is a scale-out storage. I don't explain what the difference between scale-up and scale-out is now. Basically, scale-out means you can add as many servers continuously as you want, and you gain more capacity, more performance out of the system. And the system is self-healing, which means whenever something breaks, the system tries to self-heal himself to get the health OK status, even though some disks might be broken or lost or server might be down. It supports several access protocols. First of all, the Raiders block devices. These are block storage devices we can use for multiple purposes, like a block device on any Linux server. We have native object storage APIs, and we have S3 and Swift protocols. We also support Ceph now with active-active setup for the metadata servers. We have iSCSI protocol access. We have NFS and CIFS access. NFS is interesting. It supports NFS access to S3 storage, even though I'm not sure if anybody's going to use that.
I had a customer a couple of weeks ago who was looking at that.
Who tried it? Or was that a good use case for it?
They tried it.
OK.
Yeah.
So basically what that gives us is I can store objects to S3 and access them through NFS on another server. So the background basically is for migration purposes. I'm not sure if anybody is using it for other things these days. And we have a very simple and fast deployment infrastructure. So we use Salt underneath, and we developed DeepSea on top of it, which makes the deployment very easy and very fast. Yeah, and finally, we also have some graphical interfaces for the managers normally, and also for monitoring and alerting later on. In version 5.5, we use OpenAttic and Grafana and Prometheus. And because all these text slides are pretty boring, someone told me I should add a screenshot. So that's what I have done. And I wanted to show you a few things what are possible these days with Ceph. So first of all, what I want to show is we have a big cluster here. This has 100 nodes. And each of the nodes has 24 disks. And what we learned in this environment is there is always a failure. When you buy 100 servers, several of them are dead on arrival. Some RAID controllers are broken. Some caches are not OK. The batteries of the RAID controllers are broken, whatever. There are a lot of failures even on arrival. But what you see here is the system is self-healing and tells us, even though we have these failures, we have 48 lost disks, basically, everything is OK. And the OK means we defined what fault tolerance we want to have, how safe our data should be, and this tells us exactly what we told them is achieved, and that's why we are happy. The other thing I wanted to show is, in this cluster, we did some basic performance testing. This was with 10 clients. These were OpenStack compute nodes. And we just did a basic Rados bench against that. And what you can see here is, within this system, we reached 50 gigabyte per second write performance. So that's one double-layer Blu-ray per second that we could write into that system. And I find that really impressive because that's cool. And even though we were writing so much things and big data, the latency was still pretty OK. So what I wanted to show here is, with Ceph and software-defined storage, we can do great things. And if we follow the right process, look at the requirements, take the right hardware, we can achieve requirements that are even very high here.
And that's because the 50 number is because they're bonded at 25 gigs, right? The network stack was bonded at 25 gigs?
I can't remember the details, but we were using 100 gig Ethernet technology, several bonded NICs, 25 gig each, and yep. And we had 100 nodes, so the whole I/O was parallelized amongst all the nodes. That's basically the reason why we could use that bandwidth. OK. So what requirements do we have to take care about when we're looking at SUSE storage? First of all, the solution is not off-the-shelf storage. So you have to combine several things. First of all, you need a piece of hardware. Without hardware, you can't have storage. We don't discuss the virtualized storage thing. That doesn't make much sense. So we need a piece of hardware. We have several partners. Just make sure that it's yes certified, so less is guaranteed more or less to work on it. We need a piece of software. That's basically what you get from SUSE, the SUSE subscription. And that includes SLES as an operating system part where you need it. And it also includes for several components the SLEHA, the clustering solution, to make some components fault tolerant. Once you have hardware and software, the next thing is you need to have some knowledge how to size, design, implement the thing. And that's why you need some sort of services. Normally, we need two ways of services. First of all, you need some sort of pre-sales assistance, which means somebody needs to help you with selecting the right hardware for your use case before you buy the hardware. So that's, from my point of view, a very important thing, because from time to time, I come to a customer that already has bought the hardware, and then I have to tell him, unfortunately, with what you bought, you cannot achieve what your requirements are. So that's
a common, one thing I've seen with a couple of customers now is that they decided, okay, I'm going to have a mixture of SSDs and spinning disks. And you get there and they say, this was more the case historically when we were putting, when we were doing file store and putting the journals on the SSDs, and there was a certain sweet spot ratio. And I went to a customer once, they had 36 spinning disks and 2 SSDs in each chassis. The ratio, so they were planning on putting 36 disks worth of journals on 2 SSDs. They weren't even NVMEs, were SAS attached. That ain't gonna fly. And the problem was they bought the hardware, it was sitting there.
So basically, before you buy the hardware, try to ask someone for help to decide for the correct hardware that fits to your use case. And once you have the hardware, you also might need assistance with the implementation of it. So instead of you trying yourself, reinventing the wheel, maybe also there it makes sense to ask someone from help. So basically we have consulting within our company. We have a lot of partners that can help with that. And we also have trainings. I think I forgot the training topic on this slide. Okay, after the implementation, the next thing is you need some sort of support because storage is important. And if there is any issue, you might want someone available on a phone if that can help you dial in, fix whatever is broken. So as part of the subscriptions that we as SUSE deliver, there is also 24/7 support included. So you can open up a service request and you get help. And that's the reactive support. We also offer SUSE Select as a proactive support. This is something where you can have different stages, bronze, silver, and gold, I believe. Can't remember the name. And this is a proactive approach. So on a regular process, you get someone that either visits you, depending on what you buy, does a review what's currently running, looks at the logs, etc. Basically, it does a proactive analysis of your system. It helps you scaling the system. So if you want to have more servers added or add a second data center, figure out what's the right approach for that. And it helps with upgrades. So when you do an upgrade once a year, we deliver a new version normally. So you have to go through an upgrade process, which also has one or the other challenge sometimes. And that's basically covered with the SUSE Select. So we have from the hardware over software, services, and support. We also have the maintenance assistance after that. So these are the general requirements that you need to take care of. The next thing is we have to know what's the use case where you want to use the storage. So you have to ask several questions. First of all, what's the I/O workload? What bandwidth requirements do I have? What latency is acceptable? How many IOs per second do I need? And what is the read and write percentage? Maybe also what size of IO do I plan for? And does anybody know this today here in the room? What are your requirements in that area? So can you define that? If I would ask you, you're going to buy a new storage, what are these parameters? So that's the next step where you might need to talk to one or the other pre-sales or post-sales guy to help you with finding out what fits to your use case in these areas. Then, once we know the I/O workload, we have to figure out what access protocols do you need. Which set of clients do you want to connect to this storage? Do you want to have a Ceph access, SMB protocol? Do you need NFS? Do you have native Linux clients that are connected? Do you use S3 protocol? Do you have special applications, like a backup application that can back up data to the S3 gateways? Do you need iSCSI? Do you want to use Cephfs? So basically, you need to come up with the list of access protocols that you want to use so that we can do the design properly. The next step is you have to define what availability requirements do you have. Do you have one data center, two data centers? What's acceptable, losing a single server, losing a single disk, losing a full pod or a rack? For what failure domains do you want to have that set up in your environment? Then, obviously, that's the biggest, or that's the easiest one normally. You need to know what capacity do you need. Do I need 100 gig, a petabyte, 50 petabyte, whatever? And also important, what is the growth rate that you expect? It makes a big difference if you have 1% growth rate or if you have 70% growth rate per year, exponential, whatever, because that's basically the design question, how many servers you add with which capacity over time later on. Then, anybody responsible for budget here? No, not. So you obviously need to know what budget do I have for this so that I can fit the hardware also based on the budget. And finally, you have to discover your company internal politics, religion, philosophics. Because when you come up with a software-defined storage, some parts in your company might be happy about that. So if you go to the server team, most often they are really happy about software-defined storage because they have 1,000 servers already and adding 100 more doesn't matter for them. If you go to the proprietary storage guys that are used to buy off-the-shelf storage, they might not be too happy with the need of server installation and all the complexity that comes along with software-defined storage. So this is basically what I mean. You have to look into your internal politics and talk to the right people to make sure that the solution is really accepted and yeah. Okay. So once you know all the requirements, the next step is you can go into planning and sizing. Without having all these requirements, don't even try to do planning and sizing. It can only be false. So we have that on a regular basis that someone wants to have a sizing but can't tell us any requirements, and then it's really hard to figure out the right thing. And when we're talking about the sizing, normally the first step is to look into the disks that I'm going to use, the storage devices. That's the first thing I need to clarify. On that level, I have to decide, do I go for BlueStore or FileStore? These days, forget about FileStore. New implementations are only BlueStore. So we don't discuss that anymore. But we have to talk about, do we use replication or do we use erasure coding? Replication normally has a specific overhead on the capacity side that you need to provide. Erasure coding is more efficient by providing the same fault tolerance, but it needs more CPU. And we need to figure out what's the right thing for the use case that you have. So I have a very simple example here. I'm not going too deep in erasure coding, but with this example, I think you can come up with the erasure coding yourself. So basically, I need to take the capacity requirement that you have, multiply that with my replication. So normally, the normal setup is that we have a size of 3, which means I have one original copy and I create 2 additional ones. Never ever go for 2 copies. Why not? If you have a checksum difference, how do you figure out which one is the right one? So for that reason, that's one of the reasons why we per default have a replication size of 3. And in bigger environments, or if you have multiple data centers, 4 data centers, the replication size might be 4 or whatever. Depends on your requirements. And finally, we also have to take care of the, Ceph is not very nice to us when the cluster is 100% full. So basically, it stops working once one disk is full at more than what we allow to be stored on the disk. So normally, we have around 85% what we can utilize. And for that reason, I always try to calculate a buffer of additional 20% into the picture. So basically, I take the capacity I need, multiply that with the replication size I plan for, add the buffer of 20%, and that gives me the total capacity I need to provide from a disk point of view. And with the example of I want to have 1 petabyte, basically that means I need to have 3.6 petabyte capacity in total so that I can store 1 petabyte data. And then I have to come up with the question, what's the best disk I can use for this data? So is it a 4 gig, a 6 gig, a 8 gig? Which performance do I need of that disk? And in this example, I just selected an 8 terabyte. Normally, I just look at the price versus performance or price versus gigabyte. And in this example, we come up with, we need 468 terabyte disks to fulfill the capacity requirement. So I think that's pretty clear to follow. And yeah, the next thing is I need to decide on the disk type. So depending on my performance and bandwidth requirements, basically we have 3 different disk types that we can choose of today. We have spinning disks that have around, so that's gut feeling, it depends on what device exactly you buy, but normally I see between 150 and 250 megs with current disks per sec. The disadvantage is they have high latency normally. I can use SSDs. They have higher performance and they have a much lower latency. And I have the high performance devices, the NVMEs, which are in the 2 gig range. Some are faster, some are slower. And these provide the lowest latency. So depending on my I/O patterns that I expect to run against that cluster, I need to decide which of these disk types are the right ones for me. Just a word regarding SSD and NVMe. Normally, I recommend my customers to use NVMEs instead of SSDs because you get 10 times the performance for just double the price. But that's, yeah, that changes daily. So basically, you always have to talk to your hardware vendor what's the best choice for your scenario. We can use combinations of disks within Ceph. So basically, we can go with spinning disks only, or we can use combinations where we say we take a fast set of disks for a fast data pool and another pool for spinning disks. Or we can do a combination, which means I can use spinning disks and offload a write-ahead log and the metadata DB we have for the OSD on a fast disk, which can reduce the latency to the NVMe speed for write operations, while still having the cheap HDD in the background to store the data later on. So most often, when we deploy Ceph these days, it's a combination of a lot of spinning disks with a few NVMEs. Question?
Yeah, just that on the NVMEs, one thing we've seen is in deployments is folks actually using more than now Blue Store using more of the capacity of NVMe because it's so expensive. It does allow you to get 1 to 12 as opposed to 1 to 4 in your ratio, but actually putting real data there and not using it just for caching, or in this case with Blue Store, just using more data than not, but actually using it for additional performance as well as like a performance tier, so depending on volume there, for example, or like a database or something, as opposed to just like so we've seen that as well. So you can actually recover some of that because they are so expensive and not just throwing it with everything else.
Okay, this was a bit much to repeat now for the recording.
I mean, I guess my question is, what are your thoughts on using that for beyond just tiering it and throwing it into the ratio and putting it in the Blue Store? Where are you using it in?
So the question is, for which situations are we going to use NVMEs these days?
Right, and then would you be able to use that to pin volumes? What are your thoughts on pinning volumes to that for that as well?
So basically, we have both scenarios. We have customers that use the NVMEs just to offload the write-ahead log and the RocksDB to them to speed up the latency. We also have customers that create pure NVMe pools for high performance situations. So one example is in one of the clusters that I've built, we had a single NVMe pool where we could achieve a 1 millisecond latency for 4K random I/O writes. And for some use cases like hosting SAP HANA on the system, such scenarios are valid. But you always have to look into the details of what is the requirement, and we can mix it up however we need it.
So my question was, can you combine? Are you okay with combining that? In other words, taking both those and putting it on together on NVMe?
So the question is, are we okay with taking one NVMe and sharing that for write-ahead log and RocksDB plus data?
Yes. Because say it's a very large NVMe, for example, and you paid a lot of money for that NVMe, is that okay? Are you okay? Is SUSE okay with doing that?
Technically, I think it's not even supported today.
It is supported and it will work just like you can put all of that on a single hard drive. You can also put it on a single storage.
Okay, technically what you can do is you can partition NVMEs and present them as separate basically devices, and then you can do that. But it really depends on the details of the setup. So even though it's technically possible, I personally think from an architecture point of view, separating it makes more sense, especially when we come to the failure domain topic. Because if you have data on it, and if you have write-ahead log and RocksDB from other OSDs on the same device, if that device fails, it has an impact on many components, and that's why from an architecture point of view, it might not be the perfect one. But even though it might be possible, and we have to look into the details if it makes sense. Okay, I'm running out of time. Next topic. So once we have settled what disks we need, we have to look at the network setup. Basically, today we are using, the majority are two different technologies. We use either 10 gig or 25 gig interfaces these days. There are some exceptions to the 40 gig interfaces, but I see most of the 10 and 25 gig interfaces. And from a bandwidth point of view, that means if I have a 10 gig interface, I can transfer 1 gigabyte roundabout. And on the 25 gig, I can use 2.5 gigabyte per second. And we always try to ensure that the cluster network is twice as thick as the public network. So the cluster network is used for replication and recovery. And because in replication, we have the write amplification. So we are writing, for example, with 1 megabyte per second through the public network to the system. Then we have to create 2 copies, which is basically the double of the incoming what we see on the cluster network. And that's basically the reason why one of the reasons why we want to have the cluster network thicker. We don't want that this is a bottleneck during normal I/Os. And if a node fails and the cluster needs to recover, this bandwidth basically limits how fast the recovery can happen, and we get the health okay again. So for that reason, make sure you have a thicker cluster network than what you have on the public network. Most often we use bonding for fault tolerance and combining the bandwidth that's available, and we use LACP. With the layer 3+4, we have to be a bit careful because that does not work in all environments and with all switch setups. So basically, sometimes we use layer 2, but that's something we need to work out on each different network setup. And what we always try to achieve is we want to try to balance the bandwidth on the network to the bandwidth we have theoretically available through the disks in the server. So if I have, for example, 20 spinning disks in the server, where each disk delivers 150 meg per sec, this would be in total 3 gig what the disks in the server can achieve. And then I try to ensure that the network is capable to handle exactly this bandwidth. I want to have a balanced system. So theoretically, I can put many, many more disks in a server, but I cannot get the bandwidth of the disks out to the network if the network is not thick enough. And I run into situations where I have colliding IOs going on the network or conflicting. So I always try to balance what can the disks deliver versus what can the network deliver. So taking more disks would also require more network, basically. The decision...
There's another point there that's worth pointing out. It goes back to the earlier slide about the cost, balancing cost. In an ideal world, right, every disk in a Ceph cluster could be fronted by its own computer. Right? But when you think about it, every one of those computers would need a network switch port. And on Martin's previous slide, he had a requirement to get like a petabyte or whatever was 460 disks. That number of switch ports at these kind of speeds adds up very quickly in cost. So I think initially my own feeling was when we started doing this that we would see people deploying fairly thin servers with a reasonably small number of disks per server. But the reality has been we've seen the customers we tend to encounter are going pretty dense. Would you agree? You're seeing 24 disks per server, that kind of thing. And part of that is the cost of the switch ports.
Basically,
and the density of your licensing model also helps that because the way you license it as opposed to others out there, like Purple, for example, would be, in fact, you guys license per node as opposed to capacity and the node or proc or socket. That type of licensing will allow you to add, just like you said, I can have 24 disks instead of 12. I mean, 12, I go to 24, it doesn't matter. So, especially with NVMe and the types of ratios.
The most important word here is the word balance. Yeah. So it's not only the number of disks and the network ports, it's also the licensing that matters. It's number of clients. There are many factors that play a role. So basically, we have to go through all the requirements and then try to figure out how can I do a balanced setup of the system. And that's why I give this example here. A word between 10 and 25 gig. If you really want to have a low latency environment, make sure that you go for the 25 gig technology or 100 gig because that has higher frequency, lower latency. For fault tolerance, make sure you have more than one switch, logical, and make sure not to have too many hops over switches between the servers because also that increases latency. So there is basically the cluster I was showing you, the screenshot that was using a spine leaf architecture. I'm not a network guy, but your network guys might know what that is. It just reduces the number of hops, basically. Yeah, and take care about the other networks that are required for your infrastructure, admin network, IPMI, whatever you need. Question?
I'm just curious, as far as the network design, how does InfiniBand fit in? Are there pluses and minuses?
So the question is, how does InfiniBand fit into that picture? Basically, you can use InfiniBand with IP over InfiniBand, but I personally don't have too many customers I personally don't have any. Do you have one?
No, not
I know from our communications internally, I know that some customers are doing it, but they are very rare. So technically working, yes. bandwidth better, latency as far as I know also lower, but it's not so common than the classic 10, 25, 100 gig.
And is there a technical reason for that, or is it just?
Is there a technical reason for that? No, it's just because customers tend to buy this type of technology and not InfiniBand these days. Maybe that changes once we get RDMA, I don't know. Okay, once I know the disks and I know the network, I have to decide which servers do I need to buy and how should they be filled with memory and CPU. So first of all, that's a simple thing. We need an admin server for SUSE Enterprise Storage. And from there, we deploy the system and manage it. It's a classic slash server, pretty simple. It can be a virtual machine. And if I have it as a virtual machine, I most often have the fault tolerance for this admin server also by my virtualization environment. Some customers tend to use this also as a test client. So they use a physical one with thick network connection so that they can test with a single client against the cluster to see if the performance is as they expected. But that depends on what you want to have later on. So this is a simple thing. The next thing is you have to decide for your OSD servers, the servers that provide the storage capacity and host the disks. As I said already, make sure it's yes certified. The majority of issues we have seen were the combination of hardware with the operating system and not on the Ceph side. So the majority of the challenges was on the operating system side. And having yes certified servers eliminates the majority of these issues.
Can you talk about the OSD server real quick with the yes certified? In an earlier slide, you mentioned the hardware vendors like Fujitsu and Lenovo, et cetera. And in the CES 5 study guide that they have out now for the Academy, they advise that you split up the OSD servers amongst multiple vendors. Is that going a little bit too far?
They recommend to split the OSD servers amongst multiple vendors.
In case there's a failure that's a design flaw in one of the vendors.
So, okay, so the question is, should I mix the vendors of my servers?
Yeah, is that really a best practice?
First of all, technically, absolutely no problem. So we are totally happy with mixing, and over time, when you deploy the storage, you can add whatever you want. The problem with it is it makes the performance hard to predict because different hardware, different performance results, basically. And for that reason, normally you start with a standardized loss.
So that rule of thumb is from a reliability perspective because sometimes we get bad firmware in network interface cards or bad firmware in hard drives. And when you have the same firmware everywhere, your entire cluster fails and your redundancy mode breaks down. So it is recommended from a reliability perspective. It increases your complexity of, for the deployment, and then you get to make a business decision which one you would rather have, more reliability or less complexity with purchasing, right? Because obviously every vendor likes you to buy everything from them, right? That's the obvious.
Yep.
But reliability-wise, the approach is better.
Multi-vendor for all components can increase availability if there are issues with firmware or special drivers. Totally agree. Complexity is the other side.
It's a thing about how many nines you want in your
Okay, I need to rush a bit because we just have 20 minutes left. And we have 150 more slides. So now we go to the 25 slides per second mode. So from a CPU point of view, basically, the historical recommendation was to have around 1.5 gigahertz per disk, and more with erasure coding, because then we have to do the checksum calculation also in the CPU. But I don't have more details about erasure coding so far. I'm not sure if we have enough data about that.
For hard drives, it barely matters anymore because hard drives compared to CPUs are so slow. For NVMEs and SSDs, CPU performance actually matters, and then you have then you have other bottlenecks where that matters. And single thread performance is really important there.
Okay, thank you, Lars. So basically, that's the calculation most often where we start with. And if you have low latency requirements and if you have flash disks, you should look that you have higher frequency CPUs. So instead of using the 2.2 gigahertz, you can use the 3 something gigahertz CPUs just to be on the safe side. Regarding the memory, for file store, the recommendation was around 1 to 2 gigabyte memory per terabyte. In the server, for BlueStore, the default is 1 gigabyte for the HDDs and 3 gigabyte for the SSDs. Basically, that's the default setup. And obviously, you need to have, for the operating system, additional memory, and each OSD also needs 2 gigabyte, I believe, memory for the daemon itself. What you have to keep in mind is this basically defines the read cache. So if you have very low numbers and a read-intensive environment, the cache might be a bit low. So I see several customers that go with more memory to improve the read in their environment. So I've seen 10 or 15 gig RAM per OSD to have the read caching.
It's also worth considering filling up the RAM slots if you can, so you get full memory bandwidth.
So should we consider to get the full slots for memory full?
If you go smaller DIMMs, whichever size RAM footprint you want, if you maximise the number of slots, you'll get more memory bandwidth.
Memory bandwidth is not something I had a problem with. So the question is, what setup should I use for my DIMMs in my servers?
And you've got the choice of going big DIMMs and less slots, or smaller DIMMs, more slots, go smaller DIMMs and use more slots.
So most customers do that decision based on budget. So if they know 192 gig of RAM have this price and the double has this price, and the hardware vendors want to have balanced setups in their servers, so that's basically a budget decision most often. For the operating system, please make sure you have also 2 disks there and use a RAID 1. Because every single component is a single point of failure. So also for the operating system, we want to have 2 disks. Have a look at the fault tolerance setup. So having 1 NVMe for 24 spinners will create a single point of failure. If that NVMe breaks, the whole server basically is down. So it does not make sense if you look for the reliability, probably. And most often, you can save the money that you would invest in a RAID controller because the replication of the data is taken care of the Ceph layer, so you don't need a RAID controller in the system locally. In some scenarios, caching RAID controllers can give performance increase in some use cases, but most often we recommend to use standard host bus adapters, and we save the money for the RAID controller, invest that in memory of the server or something like that. Okay, a bit about the other services. First of all, in small environments, many customers co-locate additional services in Ceph with the OSD daemons. So the smallest environment we allow today, we support, is a 4-node setup. And in these scenarios, customers tend to have the monitors or the MDSs, whatever, on the same hosts. The bigger the systems get, the more likely we put them on separate servers because we need different, maybe for the monitors, I put separate pizza boxes in my rack because it just makes sense to have them separate the bigger the system gets from an architecture point of view. So we look at the monitors, we look at the managers. Managers always are running basically on the monitors, and the MDSs, the metadata cache services for CephFS. In small environments, we also co-locate them, and the bigger the system gets and the more data I have in CephFS and the more clients I have working against the system, the more likely I put the MDSs also on separate servers. Basically, these servers just need public network. They don't have the cluster network, only OSDs need that. Regarding the Rados gateway, also here, we put them on separate servers. Sometimes customers virtualize them, depends on their scenario. Same is true for iSCSI. iSCSI is kernel related these days. And if you have problems with iSCSI, basically the Linux kernel on the server might have a problem. So having them on separate machines, not on the OSD servers, is something I would highly recommend. Yeah, and NFS and Samba, we put them normally on clusters outside.
In that line, that word client is important there. From the perspective of the Ceph cluster, all of these things are clients. So if you connect from an iSCSI initiator to an iSCSI gateway, that the data you write goes across that network between those 2 points. From the gateway, it goes to the Ceph cluster. So if that's the same network, you're doubling on the network. If that's the Ceph public network. So that's what the recommendation here is, that really these things should be on a separate network because they're actually clients, and their clients shouldn't be on the same network as the Ceph traffic. Does that make sense? Yes.
Thank you. Fault tolerance of the Radius gateway basically is done with separate load balancers. Can be a software one, can be a hardware one. You have to think about where do I do SSL termination. And for NFS and Ceph success, basically we deliver SLI-HA that you can put in your environment, at least with 2 separate servers, where you can host that and have fault tolerance. And for Samba, also scale out functionality. So I think Samba, we support up to 6 nodes, 6 or 8, I can't remember. David Disseldorp has a session about that, maybe he can say that. All right, so these are all our planning things. So we are ready to buy the right hardware after we have done the proper design for our use case. And then we have to look at what steps do I need to follow when I want to deploy Ceph in my environment then. So a few things are in the preparation first. Before you do anything, after you order the hardware, you review once more before you deploy if it really fulfills your requirements. That's normally the situation when I could come to the customer and he has already bought hardware. We review and stop if it does not work out. Then we do the hardware installation. A few things here. I always take pictures these days of the servers after they are cabled, because when you look at the console or when you do an SSH later on, you have no clue which cable goes where. So I always take pictures there. I update the firmware, and I do some basic firmware and BIOS settings to standardize this amongst all these servers. Basically, in the BIOS, I disable everything that's not required, like serial ports. Nobody uses them today anymore. Network boot, power saving. Most often, I also disable the opt-ROM for network interface cards, because in these systems, pretty often, we have maybe 12 network interface cards in the server. And when you boot the server and it tries to go through each and every NIC, it takes 5 or 10 minutes just to check each and every NIC if there is a boot option or whatever. So disabling the opt-ROM for these NICs makes a lot of sense to speed up the reboot process. I configure date and time. UTC is the key here. I make sure that the time synchronization in the customer environment is reliable. So we want to have at least 3 NTP sources that are independent of each other. So if you only have a single NTP source, basically the biggest cluster will have a single point of failure in the end. And I make sure that the name resolution is set up properly, DNS. We have to make sure that each and every IP address is resolvable forward and backward. And each IP address needs a different name. Finally, I highly recommend that etc host name points to the public name of the server. So if I have 3 interfaces in the server, public, cluster, admin, whatever, etc host name should be the public, because that makes the management with DeepSea later on easier. Okay, then, as a preparation step, I have to have some software staging system in my environment. It is very important that the servers you install are not updated and patched directly against SUSE Customer Center, because that means you install one server today with patch level of today, SUSE releases a new patch overnight, and you install the second server tomorrow, and that will get a different patch level. And we really want to make sure that all servers in our cluster have the same patch level. That's also true when I add a server weeks later, because I want to extend the capacity, then I want to have the same patch level that all others have. So as a staging system, we either have Subscription Management Toolkit, SMT, which is part of /12. With /15, we get the RMT. RMT doesn't have staging anymore. The only way I can go there is disable the cron job to replicate the channels. And we offer SUSE Manager, which has enterprise capabilities for staging different patches. So in small environments, SMT or RMT is fine. In bigger enterprise environments, you should look into SUSE Manager. Or there are also other third-party tools out there that can help with that.
10 minutes, Martin.
Yep, thank you. For the operating system installation, SUSE recommends to use BetterFS for the operating system, gives us snapshots and rollback and things like that. Disabled firewall, UpArmor. Basically, this changes now because we add more functionality with UpArmor profiles soon, or I'm not sure what the status there is, but we improved here a bit, so that might change soon. And we always change the CPUs to performance because we do not want to have servers deciding that they can go to sleep or on vacation while others might want to do I/O. Server installation should be fully automated as far as possible. Reason is all servers need to be installed identical. If a human being does it, all are different. So SUSE has AutoJust that allows the full automation. And from a consulting point of view, we have developed a framework around that that makes the usage of AutoJust pretty simple. So if you want to have a look, just check that out. After the installation, configuration management helps a lot to make sure all the servers are configured the same way. Some things are not easy to configure in AutoJust, and some things need to be changed later on also. So I need some sort of config management. In small environments, I just use a set of template files that I copy over. In bigger environments, I use Salt. Okay, oops, sorry. Verification. So I always verify time synchronization, name resolution. And before I deploy Ceph, I always test all physical components. I test the disks or the storage devices. I test the network. And I test bandwidth and latency for the network and for the devices, because now I can test them. Once they are OSDs and have data, I can't test them anymore. Okay. After that, we go through the simple process of using DeepSea. So we set up Salt. We set the DeepSea grain, which is nothing else than a tag on a server that tells me, yes, DeepSea is allowed to touch that server. I configure a few settings in DeepSea, and then I can run through the orchestration stages. First, I start with 0 that does some preparation or patch and update the server. Stage 1 looks out or checks what disks do I have in the servers, what network setup do I have. Then I can prepare the profiles, how my storage should be set up. Do I want to have file store, blue store? Where do I want to have my database and my write-ahead log, etc.? I configure the policy CFG that controls where do I want to have which daemons installed later on. And then I run stage 2, 3, 4, and my cluster is up and running with all the gateways I want to have. So this process, basically, after I have decided for the whole design, this process normally takes maybe half an hour. And it does not matter if the cluster has 10 nodes or 100 nodes. 100 nodes takes a slightly bit longer, but it's not longer than, I think with the 100 node was 45 minutes or so. All right, 5 minutes left. After I went through the whole DeepSea process, I have to go to the Ceph configuration part. So within the Ceph configuration part, I have to adjust the crush map that basically controls which data goes to which disk, in which data center, in which rack, etc. I have to create some rules that I can use for pools that then say, when I create a pool with this rule, store the data within the crush map in this specific area. Then I create my new pools, where I store my data later on. I adjust some gateway settings, Rados gateway, port, SSL settings, things like that. And then I verify the functionality. This is just a basic functionality test. Can I connect to a Rados block device? Can I access Cephfs? Just to verify that the functionality is there. And after this, I come to the most important thing, and I just have 3 minutes left now. Basically, no cluster behaves the way how you assume it behaves if you did not prove it by testing it. So we are all human beings, and we all assume that what we are doing is right, but in all the clusters I have deployed, I have found issues during testing. For example, that one or the other network port was not connected the way I thought it, or the VLAN tagging was not set up correct, or whatever. There are always some human beings there that do mistakes, and during testing we have to find these issues, fix them, and only then I can really use the system afterwards. And for the testing, first of all, you have to do preparation. Don't do testing without a written test plan. And within that test plan, basically the test plan is based on your requirements that you have defined. And here you describe the starting point. How much data do I have in the cluster? What clients do I have? What data do I have, etc. I describe the test details, unplug cable 1 in server 1 for the public interface, and I write down the expected results. I write that down before I execute it, because otherwise it happens that you execute the test, and while you're executing, you're changing your mind. And that causes failures in the tests. So first of all, we write that down, and then we are executing each and every test, and we are documenting each and every step that we're going through up to the result, and we compare the result with our expectation. And it's green if both are equal. It's not green if my expectations are not correct or if they are not fulfilled. Sometimes I also have to correct my expectations, but I only realize that here. And from time to time, we have to repeat the test multiple times. Two sets of tests. First of all, fault tolerance is more important than performance. Data reliability most often is more important than fast data. And that means I do fault tolerance testing. I test the network failures, single NIC, multiple NIC, switch failures, etc. I test disk failures. I test server failures. If my requirement is I have to survive a data center failure, I have to test a data center failure. Basically, that means I have to power off a data center. Most customers are not brave enough to do it, but if you really want to make sure that it works, you have to do that test. Okay, and then I go to the performance testing. Regarding performance, most important thing is you have to create a baseline. Baseline means after the initial deployment, you do the full stack test from the bottom to the top, and you document that so that you later on can repeat these tests and compare it to the baseline that you created right after implementation. And you can repeat these tests if they are not destructive, even later on to verify if a new patch set or a change on the hardware setting or a change in the BIOS setting, whatever, had any influence compared to the baseline. Most performance issues that we get reported in support are on the application layer. So we get a complaint, SAP database is so slow against Ceph, and then we're asking for the intermediate steps, and we can't get an answer. And then we have to do that in a running system, go through each of these steps, and we don't have anything to compare to because each and every setup is different. And for that reason, I highly recommend to go through the baseline right after deployment, document that, and where possible, repeat that also on a regular basis. after each patch, once a month or something like that, where it's possible. Okay, so I'm sorry, we are already 22 seconds over time, so I'm opening up for questions now. Are there any questions?
For those tests, do you have a prescribed set of tools that you use or scripts that you use?
Yes, I have, but I don't have it in a way that I can share it openly at the moment. But I'm working with documentation because I want to have that documented, and hopefully we can get it in there.
Yeah.
To make them comparable, that's the most important thing.
One point on that, this is important, is that, I mean, it does mention here tools, DD for raw disk and FIO, and iPerf for the network. But one thing that's very important to bear in mind is that there isn't a standard set of tests because the use cases are different. When you look at things like block sizes, you know, how is your data? Do you have a small number of large files, large number of small files? So it's difficult to give a sort of a standard set. Just run these commands. That's our standard testing, because that won't reflect the reality of what you're actually going to do.
That's a bit more of the application. It sounds like the first one, do baseline, then cluster tests.
Right, but even then, you know, things like block sizes and that make a big difference. And so if you're doing even low-level tests, you need to be testing in a way that matches your I/O pattern.
So the most important thing is that you do these tests and document them with whatever tool you decide to be able to compare yourself when you repeat the tests later on. And just come to me later, I can tell you what exact commands we're using. But for the moment, we are basically running out of time. Mm-hmm. So any other questions? No? Then I would say thank you very much for coming here and listening to us. If you get the survey email, I don't know if they send out surveys, please fill it out honestly. I want to have we want to have real and honest feedback. We are Germans. Or I'm a German guy. I would love to have direct and honest feedback. Just kidding.
I'm Irish.
You don't care anyway. Thank you very much.